Hello everyone. Let's look at today's Leetcode problem 7290. Before starting this problem, let us look at motivational quote for the day. The greatest amount of wasted time is not getting started. And this also relates to the problem that we are solving. So we always need to get started in uh, something, and then we always need to keep going, and we always need to figure out a way to move further. Maybe whether it's a small uh, piece of idea that gets connected to what we are trying to do, right? Let's try solving this problem. Let's understand the problem statement. So it says we have two types of tiles, which is 2, 2x1 and a Domino shape. So, and given an integer n, return the number of ways to tile and 2 into n board. Since the answer may be very large, return modulo 10 power 9 plus 7. In a tiling, every square must be covered by a tile. Two tilings are different if and only if there are two 4-directional adjacent cells on the board such that one of the tilings has both squares occupied by a tile. Okay, so let's understand this problem. What does a domino mean? So a domino can be of a shape 2x1 and a tromino is of shape either or this is a tromino and this is a domino that is either horizontal or vertical. So it is also given that you may rotate these shapes, and we are required to find the number of uh, ways we can tile a 2x board. So this is the question that we are looking at. Number of ways to tile a 2x board. So let's look at the example and let's see how to solve this problem. So in case of example 1, we are asked to we are given with an n is equals to 3. That means 2 cross 3 board. So let's say we would be having 2 rows and 3 columns. 1, 2, and 3, and 2 rows. So there are five different ways uh, to solve this. So that and the output that we need to return is 5. Okay, so let's see how we can solve this problem, or let's see how we can arrange uh, the tiles, maybe a domino or a tromino, to fill out all of these squares. So we need to have all of these squares filled out. So that's another criteria. Every square must be covered by tile. So that's another problem statement. Okay, let's see different ways of uh, filling this board. So one way is a domino. All three might be a domino. This is one way, and another way will be having to place two dominoes and add on. Okay. And another set of way is having to use a Tromino where this is a Tromino and this is another Tromino. So we can also have these set of shapes, maybe a mirror of this shape where we can have a domino here and a domino. These are two mirrors. And similarly, we can have two mirrors. A domino with an horizontal 2 at the start and where we had one domino here, and this is exactly the mirror. I believe uh, this example gives us an hint on how to solve this problem. So if we look closely, we are also given another example to where uh, we are given n is equals to 1, which means we would only be having 2 cross 1 tile, that is something like this. One column, this corresponds to row and this corresponds to column. And this always would be number of columns. And tiles will always be a 2 crossing row. This is something that we need to keep in mind. So by looking at these set of examples, uh, we need to understand, or we definitely need to get some sort of an hints by this example that a domino of maybe an n is equals to 4. Let's see how we can build this, and let's see if we really have some correlation on how to solve this problem. Maybe we can build a board of 4 columns. Let's see how to build this. So we can have a function, let's say f of 3 at the start. Let's say we place a domino here in a vertical way, and we might be having a set of 3 tiles that we have already devised here. So this can be f of 3, and this can be f of 1 and another f of 2. So we can bring it down to a recursive case where f of n might be a problem where we can say f of n minus 1 and f of n minus 2 and f of 1 and f of 0. And if we need to we also need to know that f of 0 is simply 1, where uh, we wouldn't be having, we are given with 0 columns and there is no type, and we are required to consider it as a 1. Just a note. And these are a few set of base cases. When we also need to have a case for Tromino. These would be set of base cases, and once we also need to uh, considering Trominos to be also having to take up some values. So we might need to devise a formula, something like this. So it would be an f of n is equals to f of n minus 1 plus f of n minus 2 and plus f of 0 plus f of 1, and Trominos only occur if a minimum of 3 cells are there. So we can again further reduce this down to a formula where we can further reduce this formula. Let me continue here. So considering a simple dominoes base case, we we said we might be having f of n minus 1 plus f of n minus 2, and it might go on till f of 2 plus f of 1 plus f of 0. And we know that this would be 1, this would be a simple 1 combination, and this might have f of 2, which is a 2 combination, either this one, or we might have horizontal domino, so the output should be 2 here. And we also need to take into account of a Tromino where and Tromino would occur only on 3 into n port. Which means we only need to take into account of n minus 3, n minus 2, n minus 4 or so. So our initial recursive call would become, this call would become f of n minus 1 plus f of n minus 2 and f of 2 plus f of 1 plus f of 0, and we also need to add in f of n minus 3 and f of n minus 4 and so on. So we can simply say this can be f of n minus 1 and f of n minus 2, considering these are not something that can be no Tromino, and 2 times f of 0 plus f of 1 plus n minus 2, n minus 3, and so on. Yeah. Okay, so this is a formula that we need to come up with as a recursive function. Let's see if we can code this up to solve this problem. Let's start off with certain base conditions. Based on this example, we can also set n is equals to and we can have a dp caching array with for the dominoes based recursive formula, so we can say n minus 1 plus dp of n minus 2, and for the dominoes then we can have okay, let's run this as code and let's see if this runs successfully. There is one final optimization that I want to highlight. Let's go back to our drawing board. So if we recall, so we said we add a initial function, say f of n minus 1 plus f of n minus 2, and we consider the Tromino's condition as 2 times f of n minus 1. So we can say, let's say if we do f of n minus 1, we end up with a formula something like this, where this can be the first part, and this comes to something like f of n minus 1 plus 2 times f of n minus 3, if we just come down to f of n. So this can be a final math formula, just a piece of math. And let's try implementing or changing our Leetcode submission to this. Let's see if the solution still runs successfully. Alright, so if you like my video, please like and subscribe. Thank you.